Welcome to David Alexander Maths Tuition. This is chapter 11c on using trigonometric identities. Okay, so what about these ones? So we need to remember that sine squared can be rewritten as 1/2 minus 1/2 cos 2x. And for cos squared, that can be written as 1/2 plus 1/2 cos 2x. And once they're written in this form, they're much easier to integrate. The integral of 1/2 is 1/2 x, and the integral of minus 1/2 cos 2x is minus 1/4 sine 2x. Double check that. Negative sine will differentiate to negative cos, and 1/4 multiplied by 2 is 1/2, so that definitely works. For cos squared, again, it's fairly similar. That's going to be 1/2 x plus 1/4 sine 2x. So just remember, with sine squared and cos squared, you're rewriting them as 1/2 minus 1/2 cos 2x and 1/2 plus 1/2 cos 2x. Make sure you remember which one is the plus and which one is the minus. Now for tan squared, we need to remember that sine squared x plus cos squared x equals 1. And from that, if I divide through by cos squared, I get tan squared x plus 1 equals sec squared x. So tan squared x is sec squared x minus 1. Oh, sorry, for these other ones I should have put on the plus c, of course. Now, what is the integral of sec squared? Well, tan differentiates to sec squared, so the integral of sec squared is tan, so that's going to be tan of x minus the integral of 1, which is x, and then plus the c. Okay, so what about for cosec squared? So for cosec squared, we know that if the f of x is cot x, then the derivative is negative cosec squared x. So the integral of negative cosec squared x is cot x. So the integral of positive cosec squared x is negative cot x plus c. Sec squared, we know that tan differentiates to sec squared, so this is quite an easy one. That's just tan x plus c. Now for cot squared, this is another one where we need to use the trig identity of sine squared x plus cos squared x equals 1. So here we are going to be dividing through by sine squared, so 1 plus cot squared x is cosec squared x. So the integral of cot squared x is the same as the integral of cosec squared x minus 1. And we know that the integral of cosec squared x is negative cot x, so that's negative cot x minus the integral of 1, so minus x plus c. So there we go. These ones not quite so bad. So some of the ones which are squared come from our trig identities, sine squared plus cos squared equaling 1. So we can see with this one we can get cot squared in terms of cosec squared, and in the previous slide we can see that we can get tan squared in terms of sec squared. Okay, so here are some slightly more challenging ones. Now, sine 4x cos 4x, that reminds me of the double angle formulae. So I struggle with these sometimes unless I write it out like this. So I know that the sine of 2a is 2 sine a cos a. So sine 4x cos 4x is a bit like the right hand side here, but instead of a, it's 4x, and it's not 2, it's just 1. So I've got 1 sine 4x cos 4x. So a is a 4x, so 2a is going to be an 8x. So that's going to be the sine of 8x. And here we can see that on the left hand side of the equation we have half of the number on the right hand side. So we've got 1 on the left, 2 on the right. So if I've got 1 on the right, then I've got 1/2 on the left. So this is the same as the integral of 1/2 sine 8x. So I know that it's something to do with cos, but if it was the cos of 8x, then that would be negative 8 sine 8x. So first of all, it needs to be negative. So negative cos 8x will give me positive 8 sine 8x, but that is 16 times too much because I only want 1/2 of it. So that's going to be 1/16 cos of 8x plus c. For the next one, I would be inclined to expand the brackets. So 1 plus cos x squared, that will be 1 plus 2 cos x plus cos squared x. Now remember in the previous slide, or maybe it was a slide before that, cos squared x, we should be rewriting that as 1/2 plus 1/2 cos 2x. So I can add together the 1 and the half, so that's 3/2 plus 2 cos x plus 1/2 cos 2x. So that is going to integrate to 3/2x plus 2 sine x plus 1/4 sine 2x plus c, and we're done there. Okay, so here are two more. So first of all, with the top one, I'm going to expand the brackets. So that is going to be sine squared x, take away 2 sine x cos x plus cos squared x. Now sine squared plus cos squared is 1. So that is going to be 1 minus 2 sine x cos x. And again, it's the double angle thing. So we've got the sine of 2a is 2 sine a cos a. And we've got, we do have the 2 sine x cos x. So that is the same as the sine of 2x. So that will be the integral of 1 minus the sine of 2x. So that will therefore be x. So that is going to be plus 1/2 cos 2x plus the c there. Okay, so tan squared 5x. So remember, with tan squared, we know that sine squared plus cos squared is 1. Divide through by cos squared, I get tan squared plus 1 equals sec squared. And tan squared is sec squared x minus 1. So what we are integrating here is the sec squared 5x take away 1. And so the tan of 5x differentiates to sec squared, but the tan of 5x would differentiate to 5 sec squared 5x, and we only want 1, so that's 5 times too much, so we need to divide this by 5. So that's a 5th tan 5x minus x plus the c. Okay, some more challenging ones here. So for the top one, that's going to be the integral of, now I've got a single denominator, so I can split this into 1 over sine squared x plus cos x over sine squared x. Now 1 over sine squared, that is the same as cosec squared x, and cos over sine and another sine, well, cos over sine is a cot. Actually, if I just write it out like so, I've got a cos on top and I've got a sine and another sine on the bottom. So the first cos, well, the cos over the first sine is a cot x, and the denominator of sine is the same as a cosec x. So what is the integral of cosec squared? Well, that is negative cot x, and cosec cot, that is the derivative of negative cosec x, so it's minus cosec x plus c. Bit nasty. Okay, and this last example on this slide anyway is cos squared over sine squared, and that is therefore cot squared x. Now remember, for cot squared, that comes from our trig identity, sine squared plus cos squared equals 1. Divide through by sine squared, I get 1 plus cot squared is cosec squared. So cot squared is cosec squared minus 1. Okay, so what goes to cosec squared? Well, same as up above, that is negative cot x minus the integral of negative 1 is negative x plus the c. There we go. Okay, so two challenging ones here. So the first one, what I'm going to do is expand the brackets. 1 plus cos x and another 1 plus cos x. That is going to be 1 plus 2 cos x plus a cos squared x over sine squared x. So I'm going to rewrite that as 1 over sine squared x plus 2 cos x over sine squared x plus cos squared x over sine squared x. So hopefully we know by now that 1 over sine squared, that is the same as cosec squared. I've got a cos over a sine, which looks a bit like that. So the cos over sine, that's a cot and a cosec. So that's plus cosec x cot x, and cos squared over sine squared is cot squared x. There we go. Right. So I know that I can integrate cosec squared and cosec cot because I recognise them as the derivatives. But for cot squared, what do we do there? So just remember that sine squared plus cos squared equals 1. Divide through by sine squared, I get 1, plus cot squared is cosec squared. So cot squared is cosec squared, take away 1. So this is cosec squared x minus 1 instead of a cot squared. So what we have is 2 cosec squared x plus cosec x cot x minus 1. Now 2 cosec, what differentiates to cosec squared? Well, that's negative cot, so that's going to be negative 2 cot x. What differentiates to cosec cot? Well, that is negative cosec x, and the integral of negative 1 is negative x plus the c. Not a lot of fun, that one. For the cos 2x, I would probably write that as, well, there's a few ways we can write it. Cos of 2x can be written as cos squared x minus sine squared x, and that is over cos squared x. So I can simply write that as cos squared x over cos squared x minus sine squared x over cos squared x, which is the integral of 1 minus tan squared x. Now for tan squared, remember that sine squared plus cos squared equals 1. Divide through by cos squared, I get tan squared plus 1 equals sec squared. So tan squared is sec squared minus 1. So it's the integral of 1 minus sec squared x take away 1. I'll just take my workings over here. So that is 1 minus sec squared x plus 1. So 2 take away sec squared x. So therefore the integral of 2 is 2x, and the integral of sec squared x is tan x. There we go. So 2x take away tan x plus c. Okay, and here's one last fiddly example. So I'm going to expand the brackets, which will give me a sine squared x minus 2 sine x cosec x plus cosec squared x. Now cosec is the same as 1 over sine. So 2 sine x cosec x is the same as 2 sine x over sine x. So I've just moved the cosec from upstairs to downstairs, and it's gone from cosec to sine, and of course they'll cancel. So that's nice and easy. And also sine squared, we can write that as 1/2 minus 1/2 cos 2x minus 2 plus cosec squared x. Now a half take away 2 is minus 3 over 2 minus 1/2 cos 2x plus cosec squared x. So what's the integral of negative 3 over 2? That's negative 3 over 2x. Negative 1/2 cos 2x is negative 1/4 sine 2x, and cot differentiates to negative cosec squared, so negative cot differentiates to positive cosec squared, so the integral of positive cosec squared is negative cot x plus c. I find especially with the cosecs, the cots, it's always worth, check your formula sheet, make sure you get the signs right as well, because it's quite easy to get those wrong. Okay, so here's a nice show that question. The key thing is remembering that cos squared x, we can write that as 1/2 plus 1/2 cos 2x. So that will integrate to 1/2 x plus 1/4 sine 2x. Okay, and that is between the limits of 3 pi over 2 and pi over 3. Okay, so let's set up our two brackets. So what is 1/2 of 3 pi over 2? Well, that is 3 pi over 4. 3 pi over 2 multiplied by 2 is 3 pi. And the sine of 3 pi is 0, so 1/4 of 0 is 0. So that left bracket is just 3 pi over 4. 1/2 of pi over 3 is pi over 6. The sine of 2 pi over 3, let's just grab the calculator for this one. So the sine of 2 pi over 3 is root 3 over 2 times a quarter, or divided by 4, that is root 3 over 8. Okay, so plus root 3 over 8. There we go. So what we have is 3 pi over 4 minus pi over 6 minus root 3 over 8. So the lowest common denominator is, of course, 24. So to go from the 4 to a 24, that is times 6. That is going to be 18 pi. To go from 6 to a 24, that is times 4, so that's minus 4 pi. To go from 8 to 24 is times 3, so minus 3 root 3. And that comes to 18 take away 4, which is 14 pi minus 3 root 3 all over 24. And that is what we were aiming for, so we know we've got it right. Okay, so here's one final example in this chapter. So we've got 7 sine squared plus 3 cos squared, and we need to show that that is the same as 5 minus 2 cos 2x. So we need to remember here that both sine squared and cos squared can be expressed in terms of cos 2x. So sine squared x, remember that that is a half minus 1 half cos 2x, and cos squared x, that is 1 half plus 1 half cos 2x. So if I expand that out, that's going to be 7 over 2 minus 7 over 2 cos 2x plus 3 over 2 plus 3 over 2 cos 2x. So that's going to be 7 over 2 plus 3 over 2, which is 10 over 2, in other words, 5. Negative 7 over 2 plus 3 over 2 is negative 4 over 2. 4 over 2 is 2, so minus 2 cos 2x. Sorted. Okay, so what we're going to do is we need to, for the final part, is we are integrating this stuff here, which is the same as what we've got up top. And the key thing is we know that that is the same as 5 minus 2 cos 2x. So what is the integral of 5 minus 2 cos 2x? Well, that's going to be 5x. Now the sine, the minus, right, let's experiment with the sine of 2x. Minus the sine of 2x. That will be minus 2 cos 2x. Okay, so there we go. I've actually done it. There we go. That is the integral. And we're looking at this between the limits of pi over 2 and pi over 6. So let's just do our 2 brackets here. So first of all, pi over 2. So that's going to be times 5. 5 lots of pi over 2. The sine of 2 times pi over 2. Well, 2 times pi over 2 is pi, and the sine of pi is 0, so that's 5 pi over 2, take away 0. We could just maybe miss that bit out altogether if you want. Now let's chuck in the pi over 6, so that is 5 times that, so 5 pi over 6. 2 lots of pi over 6 is pi over 3, and the sine of pi over 3 is root 3 over 2. So what we have is 5 pi over 2 take away 5 pi over 6 plus root 3 over 2. So 6 is the lowest common denominator. So that's going to be 15 pi take away 5 pi plus 3 root 3. In other words, 10 pi plus 3 root 3 all over 6. And we're done. We are done. But what I would recommend doing is, what is this as a decimal? Use your calculator just to check you've got this right. So this is approximately 6.1. And when you type into your calculator the integral of 5 minus 2 cos 2x between the limits of pi over 6 and pi over 2, do you get approximately 6.1? You do. So therefore we know we've not made a mistake. Happy days, we've definitely got it right.